Welcome back, folks. This is section 5 of chapter 12. We're going to look at the normal distribution from a little bit different angle this time. We're going to look at it with bent toward problem solving. Just one objective this time. So let's get rolling. So here we've got our first problem. First thing you want to do is find out where the important details are. What do we have? We've got men between 18 and 24 years, but that's all we're going to talk about, so that's not going to factor into our math part. But we do have a mean of 178.1, so mean equals 178.1. And 178, what are we talking about? We're talking about cholesterol levels. I don't know what the units are. Sorry about that. And the standard deviation for that is 40.7. Okay, those are the details we're going to be working with. And we want the percentage of men in the same age range that have cholesterols less than 239.5. Okay, how are we going to do this? Well, grab your text instruments TI-84 or thereabouts, or hit the pause if you need to grab it. Come on back. So what you're going to do is, on that TI-84, hit the second key on the upper left, then the bars key. What you're actually doing with that combination is you're hitting the distribution function. When you get to the distribution function menu, you're going to hit number 2 for normal CDF. That's normal cumulative distribution function. Cumulative density function? Anyway, you really didn't care too much about that anyway. The important thing is twofold. First of all, make sure you hit the 2 to get the right one, because number 1 happens to be normal PDF. Now, one thing you want to make sure you don't do accidentally, you don't want to accidentally pick that one. We're not going to touch that. And in fact, when you get to a regular statistics class, you won't have to use number 1 anyway, most likely. You probably will never use it. You'll always go to number 2 if you're working with that normal distribution. At least don't hit the number 1, okay? Be careful. All right, now once you do that, almost all of you are going to see a menu. And at the top of the menu, it's going to ask for what the lower bound is that you're looking for. Now, what you could put in is -1 E99. What that represents to the calculator is negative infinity. Now, it's not negative infinity, it's awfully small. And it's negative. However, it's not really negative infinity, because that's not a number. Now, here's one tip for you that I use myself when I'm putting in negative infinity or thereabouts. Since this represents a very big negative number, to make things go real quickly, I put in negative, and then I just put a string of 9s in. Something like this. Something that looks ridiculously to the left of the origin. But you can put this in if you like, if you don't mind doing that. This is sort of an easy version. I do that because it's fast. I can do it with one finger and only have to hit 2 keys. Next, once you've got that in, move down to the next line, and it looks for the upper bound. For this one, notice we're talking about cholesterol is less than 239.15, which means to the left of it. So this is the upper bound. You're going to be interested in what percentage of those men have lower cholesterols. So we want everything lower than that, but nothing above 239.15. Got the idea? Negative infinity, everything below 239.15. So you've got the first line in, the second line in. Next, you need to put the mean in here. And we already picked that out up here. It's 178.1. Type that in. Move down to the next line. And now we want the standard deviation. The standard deviation. There we go. Type in the 40.7. And you're finished entering the numbers. All you need now is to move down one more where you hit the paste. You're going to paste all of this stuff. Actually, you're going to tell the calculator, this is the information, this is how I want you to work it, and paste it onto the main screen. Now, the reason it says paste is it's going to paste it onto the main screen just in case you want to take this number and add, subtract, multiply, or divide to or from it. So, but all we care about is when you hit that paste, that it's going to hit enter, or calculate rather, hit enter. It's going to put it on there, and it's going to give you a bunch of answers. For this one, you're going to end up with 0.9332, and we wanted the percentile, and this is the area on that curve. It's one way of looking at it, because here is our 237.1, I think it was, and we're talking about what percentage are less than that or to the left of that. Here's our figure. This gives us our percentile. It's the percentile because it's everything to the left of this number. We're talking about what percentage have cholesterols of less than that 237.1 mark. And so we've got the answer. 239.15, huh? Let me check here. 239, okay. I put down the wrong number. Anyway, we've got the answer. Now, what if we, remember on the last one, we just found the percentage that was between negative infinity and 239.15. Did I get it right this time? Anyway, suppose we wanted it between two given items. This was to the left of 239.15. What about between two? Well, actually, since you're doing it this way, instead of being harder, it's going to be just as easy. So get your TI-84 busy. We're going to find the percentage in just one shot. Now, it means more than one step in a way, because you're going to be putting several things in, but once you get all those in, bingo, you'll have it. Go to normal CDF again. Remember, you go to second vars. That's for the distribution. You'll pick out, remember, it's number 2, never number 1. And you're going to use the lower and upper bounds this time. Remember, option 2, never option 1. Don't forget to enter the mean and standard deviation as well, because the default is there'll be 0 and 1. That's not what you want all the time. In fact, typically you won't unless you have z-scores, but that's a different story. So that's how you do it. Now, we've got another example, and we're going to work this out a little bit further. We want the amount of time that self-employed Americans work each week. And it's normally distributed. We need that so we can use normal CDF, for example. Here we've got a mean of 44.6. I'm going to write that down. Mean equals 44.6 hours. And a standard deviation of 14.4 hours. Notice both those have units. They're not pure numbers. Now, first of all, let's take a look at this part. We're going to take it all the way. So what percentage work fewer than 80.6 hours a week? How would we do that? Well, we're going to grab that normal CDF by going the second distribution and number 2, and we're going to put the lower bound. It says fewer than 80.6. There is no lower bound. So, for example, if I'm doing it, I'm going to do something like this, because that's close to negative infinity for my purpose, because it's nowhere near the 80.6, so this is going to work, and it's easy. The upper bound is going to be 80.6. I also need the mean. The mean is right here, ready for me, 44.6, and 14.4, close parentheses, hit enter, and I can get my answer. We'll do that in a moment. Next, what if we want the percentage that's working 37.4, between 37.4 and 80.6 hours per week? Very similar. Second distribution, I'll pick up number 2 again. You can just hit a 2 when you get there, really. You don't have to cursor down and hit enter for that. Normal CDF. Remember, that's CDF. Now, we have a lower bound is 37.4 and upper bound is 80.6. And we're going to put in the mean and standard deviation again, 44.6 and 14.4. Now, these last two numbers I've emphasized a little bit here. Even if you get in a situation where they are going to be 0 and 1, make sure you're doing it intentionally and not accidentally. So always think, okay, what should I put in for the mean and standard deviation? And that'll give it to you. So here we go. First part, the part that I lined up for you, part A if you like. Go to normal CDF, put in your favorite version of negative infinity. Remember, if you want, you can use this -1e99. That's an awfully big negative number. Here's your upper bound. You want everything less than that. There's your mean. There's your standard deviation. Once you put those in, you're ready to tell it, go ahead and do it. So you put those in, and that's what the calculator says. Translate that, because we wanted the percentage. So it's 99.38% of those men are working less than 80.6 hours per week. That's a lot of hours to work in a week. That's like 2 work weeks. Anyway, moving on. 99.38. You probably could round that off to 99.4 or maybe even 99, depending on what the requirements you have for the question. Next, the second part. What percentage are between those two? Get the TI-84, turn it on. Put in your lower bound, your upper bound, your mean, your standard deviation, and the percentage of men that work between those numbers of hours. would be 68.53%, or about 68.5%. Notice that up here we've got 3 decimal places, here we've got 3 decimal places, so it makes sense that we'd have 3 decimal places down here. That has to do with significant digits in case you're interested. And there's your final answer, and that's how it should look really. Because you've got a word question up here, so you should have a word answer to that word question. It all goes together. There's a picture of what we just did. We said it was normally distributed. There's your curve. Here's a 37.4, here's a 44.6, and there's the area slash percentage slash probability between those two. And there's some other pictures. I wouldn't worry too much about what's going on back here. Just notice that we might be asked to find the percentage that's up to a certain value. We might be asked to find percentage that's above a certain value. In this case, for example, we might have a 42, for example, as my lower bound, and positive infinity as my upper bound. And you could put that as 1E99, or if you want to be frugal with your time, you could just put a whole bunch of 9s, because compared with 42, that's almost like going toward infinity. And last of all, here's one we just finished working, where we're going from one value all the way up to a second value. And you're finding the percentage that's between those. Well, folks, that was pretty short, but sweet. I hope you enjoyed the trip. Have some good practice. You'll be an expert at this. And if you have any trouble whatsoever, bring it in. Make sure you've got your calculator the next time you come to class and ask me, or if you see something that I've never heard of before, I want to know about it. I want to become more expert. All right, you take care of yourself. See you next time.